Hello friends, in our last video we concluded that in a polynomial, the highest whole number that a variable is raised to is known as the degree of that polynomial. And we also saw the general forms of the linear polynomial, quadratic polynomial and also cubic polynomial. In this video, let us generalize the general form. That is, let us try to form the polynomial of nth degree. Since the polynomial is of the degree n, the highest power to which the variable must be raised should be n, right? So, we will have x to the power n, x to the power n minus 1, so on till x to the power 1 and x to the power 0, which is nothing but 1. If you observe how many terms are here? Here, the total number of terms is not n, it's n plus 1. Now, how about coefficients of these variable terms? We used to use the coefficients as a, b, c, d and so on. But if you use them here as well, there is a situation that we may run out of these constants. So, to overcome this problem, what we will do is, we will generalize even the coefficients or the constants as well. So, let's see how we generalize the coefficients of these variables. First of all, we take a look at each variable and the power of that variable. Now, we will take any letter a and then we express the power of the variable as subscript to this letter. That is, for the term having x cubed as the variable, the coefficient will be a subscript 3. Similarly, all the coefficients would be a subscript n minus 1, and so on, a subscript 1 and finally a subscript 0. Now, we will multiply each coefficient with its respective variable. And then finally we add them to get our general form of nth degree polynomial. And it is an x to the power n plus an minus 1 x to the power n minus 1 plus so on a1 x to the power 1, which is nothing but a1 multiplied by x plus a0. So, this is the general form of the polynomial of nth degree. Again, remember that the coefficient of the variable with the highest power can never be equal to 0. However, the remaining coefficients can all be equal to 0 since they being 0 will not affect the degree of the polynomial. Now, in this polynomial, if all the constants are equal to 0, that is, if a0 equal to a1 equal to a2, so on, an minus 1 equal to an are all equal to 0, then the polynomial formed will be named as zero polynomial. And an important point to remember is, the degree of this zero polynomial is undefined. That is, we cannot talk about the degree of this polynomial. Now, let's consider a linear polynomial p of x equals to 5x minus 10. Let's find the different values of the polynomial for the different values of the variable x. Suppose the value of x is equal to 0, then the value of the polynomial will be 5 multiplied by 0 minus 10, which is nothing but minus 10. Therefore, at the value of the variable x equal to 0, the value of the polynomial, that is p of 0, is equal to minus 10. Now, if the value of the variable is equal to 1, then the value of the polynomial will be p of 1 equal to minus 5. Now, what if the variable is equal to 2? An interesting thing happens. When we substitute x equals to 2 in the polynomial, we get p of 2 equals to 5 multiplied by 2 minus 10, which is nothing but 0. So, for the input value of x being 2, the polynomial value is equal to 0. Now, if you observe carefully, the value of the variable 2 made the value of the polynomial equal to 0. And for this reason, we call 2 the 0 of the polynomial p of x. So, we can define the 0 of a polynomial as the value of the variable for which the value of the polynomial equals to 0. For the polynomial q of t equal to t cubed minus 7t plus 6, t equal to 1 is the zero of this polynomial, since at t equal to 1, q of 1 is equal to 0. Now, if we try for some more values, we can observe that even for the value of variable equal to 2 and minus 3, the value of the polynomial will be equal to 0. So we can conclude that even 2 and minus 3 are the zeros of this polynomial q of t. So from this, we can conclude that a polynomial can even have more than one zero. Now, here is an interesting question for you. In this problem, we have been given the polynomial m of x equals to 2x minus 18, and we have to find the zero of this polynomial. We know that the zero of a polynomial is the value of the variable for which the value of the polynomial is equal to 0. So what we will do is, we will take the polynomial m of x and we will equate it to 0, and then we will find the value of x. So if we equate m of x to 0, we will get 2x minus 18 equal to 0, which implies that the value of x is equal to 9. Now, from this we can understand that when the value of the variable, that is x, is equal to 9, the value of the polynomial is equal to 0, which implies that 9 is the zero of the polynomial m of x equals to 2x minus 18. It was easy to find the zero of this polynomial, right? Now let's try to find the zero of a general form of a linear polynomial. So let's do it. We know that the general form of a linear polynomial is ax plus b. Now, to find the zero of this polynomial, we have to equate it to 0. So we get x plus b equal to 0. Now, we subtract b from both the sides of this equation, and doing so, we get ax equals to minus b. Since a is not equal to 0, we can divide both the sides of this equation by a, and doing so, we will get x equals to minus b by a. So we can conclude that for the value of the variable x equals to minus b by a, the value of this polynomial is equal to 0. Therefore, we can conclude that the zero of the general form of a linear polynomial, which is of the form ax plus b, is equal to minus b by a. So friends, that's all for today. In our next video, we will be looking at zeros of the polynomials from a different point of view, that is, by using the remainder theorem. As of now, let's summarize what we have learned so far. A general form of a nth degree polynomial is an multiplied by x to the power n plus an minus 1 x to the power n minus 1 plus so on a1x plus a0. Zero of the polynomial is the value of the variable for which the value of the polynomial is equal to 0. A polynomial can have more than one zero. For the general form of a linear polynomial, that is, for the polynomial ax plus b, the zero of that polynomial is minus b divided by a.